I'm Dr. B, your chemistry teacher. Today we are going to be discussing exothermic and endothermic reactions. This topic is under what we call thermodynamics. Thermodynamics is quite large, but there is something important about thermodynamics. Thermodynamics is built on three basic properties. One, heat. Two, energy. And the last is work. So thermodynamics has to do with the interrelationship between heat, work, and energy. And today we're going to see how these things play their role in exothermic and endothermic reactions. Do you know that every activity man carries out, that you carry out in your day-to-day dealings, has a way of contributing heat energy either to the environment or have a way of accepting or absorbing heat energy from the environment. So whether heat is given out from whatever you are trying to produce or prepare to the environment, or heat is being taken in from what you are trying to do, you have already contributed to exothermic or endothermic reaction. And as a whole, you have contributed to thermodynamics. Now let me give us a little instance. Do you know that you usually burn candle? And when you burn candle, what is happening? When you burn a candle, you are releasing heat energy to the environment. The candle is a system where a reaction is already taking place. So you are releasing heat energy to what? The environment, the surrounding around the candle you are burning. That in itself playing the role of an exothermic reaction. That means exothermic reactions are reactions whereby heat from the system is released to the environment in the course of the chemical reactions. Do you also know that when you keep a bowl of food that is hot and then you are waiting for it to get cool, you are already contributing to exothermic reactions because the food is getting cold by releasing heat energy from the food that is the system to the environment. Whenever there is a release of heat from a system to the environment, it leaves the system to be cold. Do you also know that whenever you turn a concentrated acid into water, trying to make a solution of that acid, there is a release of heat. No wonder in the preparation of standard solution, you are advised to sit the round bottom flask that contain water in a water bath or in a bucket containing water so that it doesn't get break. This is because when you turn the acid into the water, it is going to generate heat. It gives out heat, and that is why the water turns immediately to become warmer. In some cases hot, depending on the concentration of the acid. So many processes are there that we do every day that give rise to what? Release of heat energy to the environment. And that in itself is exothermic reaction. So what are endothermic reactions? Endothermic reactions are simple reactions that will allow heat from the environment to do what? To get into the system. We have typical examples. Photosynthesis. I'm sure you know about photosynthesis, where plants do what? Manufacture their foods by absorbing sunlight. Did you hear the word absorbing sunlight? So in that process, plants are getting in what? Sunlight. And as far as that is concerned, the system, which is the plant, begin to get hotter and the environment became cooler. Another good example is evaporation of water. Do you know that when you keep a bucket of water and the sun, for it to get warmer, do you know what you are doing? You are allowing the water that is a system to absorb sunlight, the heat energy into it, and therefore the water automatically become hotter as a system. And you have numerous examples, numerous exercises that you carry out that depict exothermic reaction or endothermic reaction. Let us take a look at a hypothetical diagram that describes these two reactions. Now, for exothermic reaction, we have something like this. Okay, so we have this, and then this is your reactant. This is your reactant, and this is your product. Reactant is the starting material, the product is what you aim to achieve. And then when we take a dotted line to this point and take another dotted line at this point, from here to here is your activation energy. That is an energy barrier required to do what? To be minimized or removed, if possible, to allow a chemical reaction to take place very freely and fast. We had discussed this earlier in one of our lectures when we discussed activation energy. So, from here to here is your delta H. Delta H means change in enthalpy. And for this exothermic reaction, we said heat is given out to the environment. So the system is doing work on the environment. So there's a negative work done. Therefore, our delta H becomes negative. And this particular line here is your energy. And this one here describes the reaction parts. The reaction parts. This is the reaction part, to which the reaction follows. And up here is your transition state. This is your transition state. So it means that for a reaction A plus B, you can have C plus D as the product. And for an endothermic reaction, this is how it looks like. So for an endothermic reaction, we have this. And this is our reactant, A plus B. And this is our product, C plus D. So across this point and across this point, we have our delta H heat change here is positive, because we had said that in an endothermic reaction, heat is absorbed into the system. So work is done by the environment on the system. The system becomes what? The benefiting part of that process. So it's positive, and then from here to here is our activation energy, and then this of course is our energy. Usually it is a potential energy, and then from here to here is our reaction part. And then here of course explains the transition state. This is a typical diagram. I do not want to stress us by making it quite complicated, but this is a typical diagram that explains exothermic and an endothermic reaction. Now, let's get to the main point. What makes these two different? What makes them different? But before we go into that, do you know that it is not all exothermic reactions that comes with the sending out of light energy, sending out of heat, changing of temperature. Do you know that we also have some sort of glow sticks? Glow sticks. Some are glow bangles, some are glow rings that glows light at certain processes when the reactions in them start occurring. Some you fling them in this way and they glow light. Do you know that they are also exhibiting exothermic reactions, because they are rather sending outward light from the system? So it is either light is sent from the system even though it does not change the temperature of the system, or heat energy is sent out of the system. In either case, it is still exothermic reaction. But now, what makes exothermic reaction actually different from endothermic reaction? Number one, exothermic reactions are always negative. Their heat changes are always negative. And that of the endothermic reaction is always what? Positive. Number one. Number two, in exothermic reaction, heat is released. In exothermic reaction, heat is released. In endothermic reaction, heat is absorbed. Did you see? That's number two. Number three, in exothermic reactions, the bonds that are formed are stronger than the bonds that are broken in the reactant. To form bonds, to a new product to come, bonds have to be formed. They are formed at the product. Now, the bonds in the reactant have to be broken for the ones in a product to form new bonds. So if it's an exothermic reaction where A plus B gives us C plus D, and it's an exothermic reaction, the bonds that are formed in the product are always stronger than the bonds that are broken at the reactant, being that the heat energy in the product is lower than that in the reactant. But it is not the same in endothermic. In endothermic, the bonds that are formed in the reactant are stronger bonds. The process of breaking of the bonds is stronger than that of the product. That is number three. Now, number four is that in exothermic reaction, where heat is given out, the system will be cooler. The system will be what? Cooler, because it releases heat to the environment. But in endothermic reaction, where heat is absorbed, the system will be what? More hotter, quite high in reactivity, and the environment will be what? Cooler. Again, number five, we need to understand that in exothermic reactions, where heat is given out, work is done by the system on the environment. That means that there is a negative work done. So the first law of thermodynamics equation, or the thermodynamic equation, will be written in this form. For this, the thermodynamic equation will be written as du is equals to dq minus dw. The minus sign here means that, do you see? It means that work is done by the system on the environment. That means the system loses what? Heat. But if it is an exothermic reaction where work is done by the environment on the system gains energy. So the equation, the thermodynamic equation, will now become du is equals to dq plus dw. Look at the plus attached to this to show you that work is done by the environment on the system. This is internal energy U, this is heat Q, and this is W, work done. Now to summarize this, I'm going to take us through a very short diagram. I want us to know that if we have this kind of a scenario, for exothermic reaction, our heat change is less than 0. This is because the heat here is given out. Work is done by the system, the environment. So it means that heat is released. This is heat. So the work is done by the system on the environment. There is a negative work done. And that was why I said, for this kind of a system, you have the U equals to the Q minus dW. Alright, this is your system, and of course, this is your environment. The outside here is your environment or your surrounding, depending on how you want to call it. And then here, we are having heat coming into the system. So this is endothermic. So this is your system, and this is also what? Your environment or surrounding. So here, the heat change is greater than 0. That is why, of course, in endothermic reaction, the system gather more heat than what? The environment to perform its duty. So much to talk about as far as exothermic and endothermic reactions are concerned, but I just want to appreciate the fact that we've brought ourselves this far, and I'm sure you've learned something from today's class on thermodynamics, exothermic and endothermic reactions. Do not forget to subscribe to my YouTube channel. Do not forget to follow my Facebook page. Do not also forget to like and to comment. Till the next time we meet again, it is bye.